Hey guys, Coach Goo here, and this is a 45, 45, 90 triangle. The end. Gotcha guys, just kidding. Let's take a look at these notes about the 45, 45, 90 triangle. Oh my goodness, that was so funny. Alright, anyways, so in this little cloud bubble, draw the illustration slash description. Here's the beginning of mine. It is a right triangle. A 45, 45, 90 triangle. We call it a 45, 45, 90 triangle because as you can see in this triangle, we've got a 45-degree angle, another 45-degree angle, and we've got our, really popular, just top state-of-the-art 90-degree angle right there. That's why this is called a 45, 45, 90 triangle, and this is a special right triangle. It's a special right triangle, okay? And this is the first special right triangle we're going to learn about. And there's a special relationship between the lengths of the sides in a 45, 45, 90 triangle. If this side, I'm using maroon, new color. If this side is X, okay? Well, this side is also going to be X. Then this side over here, the hypotenuse is going to be X square roots of 2. Dun, dun, dun. Square root radical number, dude. This is the relationship of the lengths of the sides in a 45, 45, 90 right triangle. So draw this kind of illustration slash description in the little cloud thing. Looking down here in the helpful table, we're going to fill in this helpful table. So if one side, I'm going to use, it's like a little example table. Remember what 45, the length is X. The other 45 degree, the side across from 45 degrees is also side length X. Then the 90 degree across the hypotenuse length is going to be X square roots of 2. So let's pick a number. For example, X is 5, okay? So one side length is 5, okay? The other side length, the leg, is also going to be 5. Then the hypotenuse, what length is that going to be? 5 square roots of 2. Is that what you said? Yeah, high five. Woo! Let's look at some example problems. Look on this triangle on the left. I'm going to recreate this triangle because this is a little small and I want a bigger picture. So this side is A, right? And we know that this side is 7. But remember, the two legs in a 45, 45, 90 triangle are congruent. That means we don't need to write A over here. We know that this is, scratch that out, bam, that's also going to be 7 because the two legs are congruent. Now we don't know what this side is right here though. It's labeled B on the notes, but this side, all right, let me just draw some arrows to help you see. So 45, and then the hypotenuse length is over here, okay? So these two sides are 7, then this side length right here is gonna be 7 square roots of 2. See? Remember we had X, so 7 is X. 7 is X. And then this is X square roots of 2. So we just replace X with our number. And it's as simple as that. Now let's look at our other picture. Alright, so this is what the picture looks like on the second example. We got side length A, B, we don't know what that is, and we know the hypotenuse is 10. Remember, the side across from the 90-degree angle is always going to be the hypotenuse. So that's this side, okay? So what's this angle right here? Well, we see that we have a 90 and we see that we have a 45. Then this other angle is, of course, also going to be 45 degrees. Oh, wow. Look at that. We've got a 45, 45, 90 triangle. So remember the special relationships on the 45, 45 angles. Wow. 45, 45, 90. X, X, and X square roots of 2. Well, if 10 is X square roots of 2, let's write an equation to solve for X because our side lengths are X, right? So remember, 10 equals X square roots of 2 because the side length on the hypotenuse is always X square roots of 2. This will help me find X. So if I want to get the X alone, what do I need to do? I need to divide both sides by the square root of 2. Bam. That will cancel the square root of 2 right on this side. Boom. So then it leaves me with 10 over square root of 2 equals X. Is that the answer? Is that what you got? Because you'll be wrong because you cannot have the square root in the bottom. Okay, you can't have the square root in the denominator. So what we need to do is rationalize the denominator. So 10 over square root of 2. How do we get rid of that square root in the bottom? We're going to multiply the top and the bottom by that exact square root. Boom. So 10 times the square root of 2 is just 10 square roots of 2. And then square root of 2 times square root of 2 is just the square root of 4. But that's actually just 2. So we can just write 2. Boom. Then we need to simplify, because as you can see right here, we've got a 10 over 2. And 10 over 2 can be simplified to 5 over 1. So instead of writing 10 over 2, we're going to write 5 over 1. So now it's going to be 5 over 1 square roots of 2. But we also don't need to write the 1 over 1 in a fraction, because that is just, that's not even necessary. So our final answer is that x equals 5 square roots of 2. And that is how you use these special relationships in a 45, 45, 90 degree triangle to find the side lengths, the missing side lengths. And that concludes this video, guys. So I'll see you in the next one. Peace!